Okay, so what I'm going to do is I made this little video so that you can try and do these problems and hopefully listen to me if you have questions. If not, you can just mute me. And so we're starting with some Chapter 17 practice problems. So the first problem we're going to deal with is dealing with left-handed people. And it's going to take up a couple slides, but I worked each one out. So what's going to happen is a problem's going to come up. And then what you're going to need to do is you're going to need to pause it when you're ready. So the first one is assume that 13% of people are left-handed. If we select 5 people at random, find the probability of each outcome below. There's 6 different probabilities we're going to do. We're going to do one at a time. The first one is the first lefty is the 5th person to be chosen. So pause the video, see if you can figure this out. Alright, so the first thing you have to do is figure out that this is geometric because we're looking for the first success, and we know it's exact, so that's going to be the PDF. So when we use the geometric PDF, our probability goes first, and so that's the 0.13, and then our 5 is the 5th person, and so there's a probability of 0.0745. All right, same thing. Try the next one. There are some lefties among 5 people. So again, the first thing you have to do is figure out if it's geometric or binomial. This is binomial because it is up to a certain amount, and since it's up to, it's going to be CDF. And again, it's binomial because it's saying that there's some. It's not saying just one. It's saying that there could be multiple of them. So we have an equation for binomial and geometric that goes up to, but we want 1 minus having no lefties so that we could see what happens with that. So we have the binomial, there's 5 and the 13%, and the chance of us picking none is 0.498. And so now we're going to do 1 minus that. And so that we know if we pick none, remember it's at least you always subtract from 1. All right, same problem again, another probability issue. This one's asking you the first lefty is the 2nd or 3rd person to be chosen. So what you should see is that it's geometric because it's exactly the 2nd or exactly the 3rd. But what's different about it is it has this or right here. And remember, or means that we're going to have to add. So we're going to have to find 2 geometric probabilities and add them together. So I need to find the one for the 2nd landing, the one where the 3rd person is chosen, and then we're going to add those 2 together because it's 2nd or 3rd to get a probability of 0.211497. All right, the next problem we have is there is exactly 3 lefties in the group. So take a minute, see if you can figure out if it's binomial geometric. It is binomial because it's exactly, and since it's exactly, we're going to do PDF. The binomial is going to be 5, 13%, and we're choosing 3.